In section 4, we're going to be talking about selecting samples and drawing conclusions from samples. And our vocabulary is going to deal with different terms around basically sets of people, mostly what we're talking about. So what is a population? What is a sample? What does it mean to have an unbiased sample or a biased sample? And how do you account for margin of error? So if you take a look at the idea of population, so a population is a group of people or objects that I want to know something about. So when you think about the population of the students of our school, that would be all of the students in our school. If you think about a large corporation like, say, Coca-Cola, and they're thinking about marketing a new soda in the United States, potentially they're talking about every every citizen of the United States, anybody who lives here. So that would be the population. Now, typically, when you're talking about a population, you don't necessarily want to get a response from everybody because it's simply too difficult or too expensive. So if using the Coca-Cola idea, if they want to market a new soda to the United States, they don't try to get the opinions of every single person in order to determine whether it's going to be popular. Instead, what they do is they find a sample. Okay, so they'll get a smaller set, and determining how you choose that sample and how large that sample is has a huge amount to do with how valid your survey or your study is. So when you think about different types of samples, you can have a self-selected sample. So that's where members of a population volunteer, right? So they volunteer to be in the study. You could have a systematic sample where you're using a rule to select members, right? So they can self-select. You can use a rule to select them. A convenient sample, so you go after the people who are easy. And in a random sample, each member of the population has an equal chance of being selected. Okay, so will you randomize it in some manner? Okay, so these are the different types of samples that you might have. And when you think about it, you can see that if people volunteer to be in your study, they may not have an unbiased opinion, right? If they're interested enough to volunteer, then they may already have some sort of a specialized opinion about whatever it is you're talking about. And also using an easy to reach group. For instance, if I want to do a survey and I choose to do my survey just with the members of my class, well, the members of my Algebra 2 class really aren't representative of the entire school's student population. Okay, so there are inherently, the best is having a random sample. Okay, and both of these have some inherent flaws within them. So when you start taking a look at this, you want to pick the best choice you can. So here we have an example where a sports writer wants to survey baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. So, college allows for aluminum bats. Professional baseball players don't use aluminum bats. So when you start thinking about what type of samples they are, the sports writer contacts only the coaches that he has cell phone numbers for in order to get quick responses. Well, that's a convenience sample, right? He did what was convenient. He didn't want to bother to get new contact information, so he just went with what he had. The second one, the sports writer mails out surveys to all the coaches and uses only the surveys that the coaches send back to him. Well, now that's really a self-selected sample, right? Because he's mailing it to them, but if they don't respond, he doesn't try to do anything else to make it more flushed out, his responses. He uses the people who willingly participate. Okay, so this is sort of getting the idea. What you have to look at is how did it go about? And the key thing is, in this one, he uses only the surveys that got returned. right? If someone didn't return them, if he wanted to be truly more thorough, you'd try to contact them back and see if there's a way to get them to fill it out. So go ahead and practice looking at different types of samples. Do problems 3 through 5, and then come on back. So now when we want to talk about bias sampling, so if you want to have accurate conclusions about a population from a sample, you need to have an unbiased sample. So typically, if it's an important study, you're not going to use a self-selected group and you're not going to use a convenience group because both of them have some level of bias. But what's important when you start looking at this, and also if you, as a consumer of information, when you start looking at research that people have done, which you might need to do if you're doing a research paper, you may want to look at how they chose their methods and see how did they select the people they chose. There are times when it's appropriate to use a biased sample, and there are times when it's not. So in this case, we're looking at this. The manager of a concert hall wants to know how often people in their community attend concerts. So the key here is he wants to know about people in the community. And then the manager asks 50 people who are standing in line for a rock concert about their behavior around concerts. Well, this is definitely a biased sample, right? If he wanted to know about people in the community, his selection should have been based on people chosen randomly throughout the community. By asking people who are already standing in line for a rock concert, they're going to a concert. Of course they attend concerts. He's missing out on anybody who doesn't attend, and he's going to get a very skewed response. Okay, so these are the types of things you want to look for in identifying bias. So I'm a member of the prom committee and I want to poll members of the senior class to find out where they want to hold the prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors to poll. Well, there are a lot of different ways that you might go about this, but I think one that is pretty simple would be to say, well, if there are 324 students and I want 40, that's about 1 in 8 students, right? So 40 students is about 1/8 of that population. So if we pulled out, say, let's say we pulled out the yearbook or a roster of the seniors, right? So if we take a roster listing of the seniors, alphabetically would work. And let's say then that I picked every 8th student. And then just to randomize it a little further, maybe I roll dice to determine who I'm going to start with. Maybe I'm not going to start with the first student. Maybe I roll the dice, it comes up 4, so I start with the 4th student. I pick the 4th student, and then the 12th, and then the 20th, and the 28th, and the 36th, and so on. So I pull 40 students that are relatively that's randomly choosing through the class. Okay, so that's one way I could do it. I could take the roster and I could cut it up so that each person's name was on a piece of paper, and I could put the pieces of paper in a hat and mix them all up, and I could pull 40 names out. That would be another way to do it. So anything that then is going to make it random will work. What wouldn't work would be saying, okay, I'm going to go to the dining hall and I'm going to ask the first 40 students who enter the dining hall. Okay, that probably isn't going to work because, first off, if you're going to ask the first 40, they're probably going to be coming in with their friends, so you're going to get people who have mindsets that are closer to the same. You're also only looking then at the students who are going to the dining hall that day. Many students may have brought their lunch, not gone to the dining hall. If you think about our school, a lot of people go to the gym. People bring their lunch. They sit out in the atrium. They sit out on the steps and on the benches. They go to the amphitheater. They go out in front of the library. So if you only are in the dining hall, then you're not really selecting from a full set of seniors in this case. So that's what you're kind of looking for, is how might you go about doing this? And there's not only one way. There are a number of different ways that would work. But what you want to make sure is that when you do select a method, you're not somehow introducing some level of bias, like my example about the dining hall, which is a biased selection. All right, when you talk about sample size, I mentioned this earlier, that you need to have an appropriate sample size. The smaller the sample size, the less likely it is to be accurate. And what happens is every study has a certain margin of error. But the thing you want to remember is as the sample size increases, the margin of error decreases. Okay, so it's important for us to think about margin of error. Now, if we see polls published on television, they'll say, like especially around elections, they'll say, well, right now we believe this person has this percentage of the vote and this other candidate has another percentage of the vote, and they'll say plus or minus 4%. Well, when you look at the plus or minus, often what they're really telling you is they don't know a darn thing about who's going to win. Because by the time you encounter the plus or minus 4, then it makes them virtually identical. Okay, but for our purposes, we're going to figure out how we calculate margin of error. And we have a formula right here. So it's the margin of error is plus or minus 1 divided by the square root of my population. Okay, that's great. So when we go through this, we'll have plus or minus, right? It could be this amount. This is the margin of error, so it could be that much less or that much more. So once we've considered the percent, that becomes P, and it's going to be P plus and minus the margin of error. So when we go through and we calculate margin of error, I have a survey of 1,011 people, and we have 52%. So I have, 52%, so that's 0.52 plus or minus 1 divided by the square root of my sample size, which is 1011. Okay, that's the interval. I'm sorry, I didn't read the instructions. The margin of error is just this part. So when we look at the margin of error, it will be this calculation here, which I'm going to do first. So what I want to do is I want to pull out my calculator. And I'm going to find the square root of 1011, and it's 31.79, and I want to find the inverse of that, so 1 over that, I use this. So it's 0.0315, essentially, by the time I round up, 0.0315, so 0.0315. So when you start thinking about that, this is 52% plus or minus 3.15%. So if I want to create this interval, the top end of my interval is going to be 55.15. And the lower part of my interval will be 48.85%. Okay, so this was calculating a margin of error and then creating an interval that should contain the exact, somewhere in this interval should be the exact percentage. All right, so that's using a margin of error. You go ahead and practice that, and that's actually the end of the lesson. So go ahead and do problem 6, 7, 16, and 17, and that'll wrap it up.